Good afternoon. We have been charged today with the top secret mission of getting this bottle of water to the triple point of water. And all we have is this water bottle and our kitchen. How do we do that? Well, let's take a look real quick at the phase diagram here and see what's going on, what we're trying to get to. So we're trying to get to this triple point. And what triple point means is that the water is in a state where it's coexisting in all three states simultaneously, as a gas and as a liquid and as a solid. And right here, right now, we see that there's a liquid phase along this blue line, which means whenever it's along this line, depending on both its pressure along the y-axis and its temperature along the x-axis, is the point of equilibrium. It's called the vaporization line, where it's both an equilibrium between liquid and a vapor. And we're trying to get eventually the water here to the triple point. However, we have a problem on our hands. We can't currently use this phase diagram system. And why is that? Well, it's because we have air in our system. We have air in here. It's not just purely water. So what do? We have to, the problem is, remove the air. So then the question is, how do we remove the air to get this to be purely water in this water bottle? So one option would be, why don't we just go to the sink and fill this all the way to the top with liquid water? Well, one of the issues is maybe my wife has been taking extra long showers here in the winter, and our water bill has gone through the roof, and we can't spend extra money on water to do experiments like this. Or maybe another issue would be, even if we did have water to spare and fill this up to the brim, we're not going to be able to get to the triple point anymore. And why is that? It's because this is filled with liquid water, meaning there's no space for it to be churned into a gas. So even if we had it along the vaporization line, there's nowhere in here, if it's filled to the brim with water, for water vapor to exist in the gaseous state. And so we can't fill this to the brim with water. So we're stuck with this as is, with this amount of water, and we have to get the air out. And so then what is our solution? Well, it's to boil the water in here. And why is that our solution? Well, we have to consider real quick that right now, as it stands, and before it was sealed, and when it was sealed, this right here, the air in here, is 1 atmosphere of pressure. And we know it's 1 atmosphere of pressure because there's no air rushing into the bottle, and there's no bubbles that we see at the moment. There's nothing leaving the system as is. So the air outside and in the air inside, what I should say is the pressure on the inside and the pressure on the outside and the inside is the same. It's at 1 atmosphere. And so we have to figure out how we're going to remove the air that's in this system with it being at 1 atmosphere of pressure. And so then another thing to consider is that it's not 100% air as a mixture in here. We have water vapor mixed in with the air. So it's a partial mixture of water vapor and a partial mixture of air. And then another thing to consider is that the water vapor, the pressure of the water vapor, is going to be equal to the pressure of the water vapor in the liquid. And so as we boil it, what we're going to see happen, if we look back at our phase diagram, is as we increase the temperature, as we boil, what's going to happen is that we're going to increase and increase and increase the pressure. The pressure is going to rise as we increase by boiling. And eventually, when we hit 100 degrees Celsius to the boiling point of water, we have to ask what is actually happening at the boiling point. And when it reaches the boiling point, the water vapor at the boiling point is exactly equal to the pressure of the air. That's crazy. That's great. That gets us where we need to be. So when we get this to the boiling point, what's happening is water vapor, the bubbles, begin to produce. And we know that those bubbles are purely water because they're coming straight from water. There's nothing in the water but the water. And so as it's boiling and it's producing these bubbles, and the water vapor bubbles are coming up through the surface and they break free, they're breaking free at 1 atmosphere of pressure because we've reached our boiling point, which is when water vapor is exactly equal to the pressure to 1 atmosphere of the air. And so when it breaks free from the surface, it's breaking free at 1 atmosphere of pressure, meaning it has to go somewhere. Meaning air, the air that's currently in here, has to go somewhere, and there's only one place for it to go, which is out. And because we're continuing to boil the water, water vapor is continuing to get generated and burst through the surface, and it's going to keep, water vapor is going to keep shoving all the air out. Because it's at the same pressure, the air is going to be driven out. And then once we've been boiling and we dry out all the air and it's just water vapor in here because of the same pressure from the boiling, we seal our system. And now we're left with water vapor and liquid water. So our water in our gaseous state and our water in our liquid state. That's amazing. So now we're 2/3 of the way there. Almost there, because the last thing we have to do is freeze this puppy, right? Because now it's at its boiling phase, and so now we just have to have it cool off. Because right now we are at the point where it's higher up on our liquid phase here, our vaporization line. So as we cool it down, all we have to do by letting it sit in the freezer is just give it time to cool down. And as it's cooling down, it's cooling, and then boom, it hits 0.1 degrees Celsius. And the pressure, as we can see here, as it cools down, we don't have to do anything because we're just letting it cool down. And as we're letting it cool down, the pressure is decreasing. And the pressure is decreasing and eventually hits 0.006 atmospheres of pressure. And that is when we have hit our triple point, when it's going to be simultaneously coexisting as a solid, as a liquid, and as a gas. And that is how we get this water bottle, using our knowledge of phase diagrams, to the triple point with our kitchen. Thank you.